This is an integration review. Let's take a look at problem 1. Suppose we have the integral of x minus 1 times e to the x divided by x squared dx. This can be written as the integral of x e to the x minus e to the x divided by x squared dx. Okay? And what's neat about this is we can write this as the integral of the following. So we're going to take the integral of the derivative of e to the x divided by x, and we're going to integrate this with respect to x. Okay? And we're done. When you take the integral of the derivative of e to the x over x dx, you're going to get e to the x over x plus c. And that's how we do example 1. Example 2. Suppose we have the integral of 1 over x times x to the 4th plus 1 dx. And so what I did was the following. It's a trick. I'm going to multiply the numerator and denominator by x, like so. Okay? When I do that, I get the integral of x over x squared times the quantity x squared to the second plus 1. X squared to the second is just x to the 4th. Okay? And I'm integrating this with respect to x. So I'm going to let u equal x squared. Du is 2x dx. X dx is 1/2 du. And so the integral of x over x squared times the quantity x to the 4th plus 1 dx becomes 1/2 the integral of 1 over u times u squared plus 1 du. And so this is a perfect problem to do by partial fraction decomposition. So 1 over u times u squared plus 1 is a over u plus bu plus c over u squared plus 1. And so this is where you have to do some algebra. So I'm going to multiply both sides by u times u squared plus 1. And so 1 equals a times the quantity u squared plus 1 plus bu plus c times u. And so if you notice, I distribute the a inside and I distribute the u inside. And so 1 equals au squared plus a plus bu squared plus cu. And so collecting like terms, I get 1 equals the quantity a plus b times u squared plus cu plus a. So what that tells me is a plus b equals 0, c equals 0, and a is forced to be 1. But if a is 1, can we agree that b has to be negative 1? Because that's the only way that a plus b equals 0. And with that, 1/2 the integral of 1 over u times the quantity u squared plus 1 du is 1/2 the integral of 1 over u minus u over u squared plus 1 du. So if I split up the integral, I get 1/2 the integral of 1 over u du minus 1/2 the integral of u over u squared plus 1 du. Okay? Now, this is equal to 1/2 minus the natural log of the absolute value of u minus 1/2 times 1/2 natural log of u squared plus 1 plus c. But remember, u equals x squared. And so this is 1/2 the natural log of x squared minus 1/4 the natural log of x to the 4th plus 1 plus c. Now, x to the 4th plus 1 is always greater than 0, so I don't have to worry about that being negative. which is why I don't have absolute value bars around x to the fourth plus 1. And now for x squared, this is where it depends on your instructor. Your instructor may want you to pull the 2 out in front of the natural log. And remember that 1/2 of 2 is 1. And so on the bottom line, we get the natural log of the absolute value of x. And I have to have absolute value bars there because I don't know if x is negative or not. So again, I get natural log of the absolute value of x minus 1/4 the natural log of x to the fourth plus 1 plus c. Example 3. Suppose I had the integral of 1 over 1 plus cosine theta d theta. And so the traditional way to solve a problem like this is I'm going to multiply the numerator and denominator by the conjugate of the denominator. So in this case, I'm going to multiply the numerator and denominator by 1 minus cosine theta. So this is the integral of 1 minus cosine theta divided by 1 minus cosine squared theta d theta. And so this is the integral of 1 minus cosine theta divided by sine squared theta d theta. And now, remember, a minus b over c is a over c minus b over c. And so I'm going to split this up. And when I do, I get 1 over sine squared theta minus cosine theta over sine squared theta d theta. And this is the integral of cosecant squared theta minus cosine theta times 1 divided by sine theta times sine theta d theta. I did that on purpose because I want you to realize that cosine theta over sine theta is cotangent theta. 1 over sine theta is cosecant theta. And so this ends up being the integral of cosecant squared theta minus cotangent theta cosecant theta d theta. And I'm pretty much done. So this is negative cotangent theta plus cosecant theta plus c. And let's take a look at number 4. Suppose we have the integral of sine 2x divided by 1 plus cosine to the fourth x dx. So this is sine 2x divided by 1 plus cosine squared x quantity squared dx. Substitution. Let u equal cosine squared x. By the chain rule, du is 2 cosine x times negative sine x dx. And this is equal to negative sine 2x dx. If I move the negative over to the other side, I get sine 2x dx is negative du. And so this is negative the integral of 1 over 1 plus u squared du, which is negative arctangent of u plus c, right? But remember, let's go back. Remember, u is equal to cosine squared x. So this is negative arctangent of cosine squared x plus c. And number 5 is really, really, really interesting. Suppose we have the integral from 1 to 3 of the square root of 9 minus x over x minus the square root of x over 9 minus x dx. So what I'm going to do is I'm going to let u equal the square root of 9 minus x over x. I always think it's best to square both sides to get rid of the radical. So when I do, I get u squared equals 9 minus x over x. Split that fraction up. And so what I get is u squared is 9 over x minus 1. Because remember, x divided by x is 1. And so that's how I get this line here. Now, add 1 to both sides, and we get 9 over x equals u squared plus 1. Now, pretend like this is over 1, and I'm going to take the reciprocal of both sides. So x over 9 is 1 over u squared plus 1. Solve for x, and x equals 9 over u squared plus 1. That's what I have here. So by the chain rule, dx is negative 9 over u squared plus 1 to the second times 2u du. When x is 1, okay, u is the square root of 8, which is equal to 2 square root of 2. When x is 3, u is equal to the square root of 6 over 3, which is equal to the square root of 2. So, by the way, let's remind ourselves, u is the square root of 9 minus x over x. So I'm replacing x with 1. And when I do that, I get 9 minus 1 over 1, which is 8. And that's where I'm getting the square root of 8 from. But when I simplify it, I get 2 square root of 2. And then, same thing, I just replace x with 3, and I get 9 minus 3 over 3, which is 6 over 3, underneath the radical, right? And so when x is 3, u is the square root of 2. And when we come over here, we go from 2 square root of 2 to square root of 2 of u minus 1 over u times the quantity negative 18u over u squared plus 1 to the second du. Now, you might be wondering, where did I get this 1 over u from? Now, let's back up a step. 9 minus x over x, okay? This is equal to 1 over the square root of x over 9 minus x. So notice how I flipped it over. If you're thrown off by the radical, just deal with a fraction. So like, let's say I had 2/3. If I want to put this under 1, right, I'm going to take the 2/3 and take the reciprocal. So 2/3 is 1 divided by 3/2. So it would look like that. So if we circle back here, we're going to get u minus 1 over u times negative 18u over u squared plus 1 squared du. Now, if I get a common denominator, this is the integral from 2 root 2 to root 2 of u squared minus 1 divided by u times negative 18u over u squared plus 1 squared du. Okay, the u's cancel, right? Here, let me put the u here, and I'm going to cancel the u's, and I'm going to draw my triangle, and I'm going to do a trigonometric substitution. So I'm going to let u equal tangent theta. Du is secant squared theta d theta. The square root of u squared plus 1 ends up being secant theta. So if I make my substitution, I have negative 18 times the integral from u equals 2 square root of 2 to u equals square root of 2 of tangent squared theta minus 1 divided by secant to the 4th theta times secant squared theta d theta. Okay? Now, over here, secant squared theta goes into secant to the 4th theta, secant squared theta times. So I'm going to cross this secant squared theta out. I'm going to cross this secant to the 4th out of theta and replace it with secant squared theta. And then I'm going to split the fraction. So on the next line, I'm going to go from negative 18 well, I'm going to write this as negative 18 times the integral from u equal 2 root 2 to u equals root 2 of tangent squared theta over secant squared theta minus 1 over secant squared theta d theta. Now, just kind of real quick here, tangent theta over secant theta. So this is sine theta divided by cosine theta divided by 1 over cosine theta. Notice how the cosines go away and you're left with sine theta. So I'm going to get negative 18 times the integral from u equals 2 root 2 to u equals root 2 of sine squared theta minus cosine squared theta d theta. If I switch the limits, I change the sign to a positive. So this is 18 times the integral from u equals root 2 to u equals 2 root 2 of negative cosine 2 theta d theta. So this is negative 18 over 2 sine 2 theta from u equals root 2 to u equals 2 root 2. And remember, sine 2 theta is 2 sine theta cosine theta. And then, so this 2 will cancel out this 2. And so what I get left with is negative 18 sine theta cosine theta from u equals root 2 to u equals 2 root 2. If we go back to the triangle, sine theta is u over the square root of u squared plus 1. Cosine theta is 1 over the square root of u squared plus 1. If I put all that together, I get negative 18u over u squared plus 1 from square root of 2 to 2 root 2. And if I do a bit of arithmetic, my final answer will be 2 times the square root of 2. So on this line, I just apply the fundamental theorem. And after all that work, I finish the problem. And that'll do it for this video. It's an integration review where we worked 5 examples.